right, so solving trig equations. What I first want to look at is I want to look at solving, say the sine of x is equal to 0. So when we're trying to find the values of x for which the sine gives you 0, what we have to do is we have to look at a unit circle. And you can find a unit circle, you can download it off of what we care about. So our unit circle being this. Now, the points that I'm looking for is on your unit circle, it's the y coordinates that are the sine function. So this is 1, 0, this is 0, 1. Now the sine function being, equal to 0 at this angle and negative 1, 0 being equal to 0 at the other angle, so 0 here as well. So this gives us an angle of 0, and this gives us an angle of pi. So the answers to this is x is going to be equal to, 0, and also x is going to be equal to pi. Now this works for all coterminal angles as well. So you can add 2 pi. So 0 plus 2 pi is going to be here, plus another 2 pi is going to be here, plus another 2 pi is going to be here, and even subtracting 2 pi's. So the way we do this is we add multiples of 2 pi. So we say 2 pi times n, so we say 2n pi. So this is just multiples of 2 pi. And same thing here, this is going to be plus 2n pi, where n is an integer. And another way they even say is like n is like in the integer, so they like to say z. If I want to solve other ones, say b, the cosine of x is equal to root 2 over 2. Let's say cosine minus root 2 over 2 is equal to 0. So the way we solve our equations is we have to isolate the most complicated structure, being the cosine function. So the cosine of x being equal to root 2 over 2, which means I have to find root 2 over 2 on the unit circle, but in the x coordinates. So if I look at these, we have our unit circle being here, and our x coordinates that are going to split root 2 over 2 is going to be this angle and this angle. This angle being pi over 4, and this angle being 7 pi over 4. And we can see that we get root 2 over 2 comma root 2 over 2, and this is going to be root 2 over 2 comma minus root 2 over 2. But since we're talking about the cosine, it's the x coordinates that I'm looking at. So the angles are x is going to be equal to pi over 4 plus multiples of its period. And also x is going to be equal to 7 pi over 4 plus multiples of its period. You're welcome to use negative pi over 4 if you prefer as well. So if you want to write this as minus pi over 4 plus multiples of its period, it's still equivalent. So I'm going to just keep complicating this slightly more and more to be able to isolate this. So I have to isolate the sine function. I'm going to have to add 1 and then divide by 2. So 2 sine of x is equal to 1. So the sine of x is equal to a half. Now, looking at the angles for which this is true on our unit circle, we can see that the angle is going to be pi over 6 because I get a y coordinate of a half because we're talking about the sine function. And also we have 5 pi over 6 because I get a y coordinate of a half. So x is going to be equal to pi over 6 plus multiples of its period. And x is going to be equal to 5 pi over 6 plus multiples of its period. Tangent function. So if I want to solve, actually let's do this. Let's do a secant function. Root 3 secant of x plus 2 is equal to 0. So again, solving for the trig function, root 3 secant of x is equal to negative 2. So secant of x is going to be minus 2 over root 3. Now our unit circle gives you values for sine and cosine, so it'd be better to use the reciprocal function, which is the cosine function. Remember, this is 1 over the cosine. So if I flip this to give you cosine, you're going to have to take the reciprocal of this as well. So minus root 3 over 2. Now finding minus root 3 over 2 using that, the angles on your unit circle, we can see that these angles are going to be, if you look at your unit circle, they're going to be down here. So we're talking about 4 pi over 3 and also 5 pi over 3. Because those things will give me angles of, for the cosine is going to be for the cosine to give me these angles of minus root 3 over 2, we're actually looking at, actually that's wrong. So we're looking at, let me just draw these again. I think it's better if I just put them over here. So if we're looking at minus root 3 over 2, we're looking at this angle, which is 5 pi over 6, because I get minus root 3 over 2 in the x coordinates. And also for minus root 3 over 2, I get 7 pi over 6. And this gives us a minus root 3 over 2 in the x coordinate, because we're talking about the cosine. So x is going to be equal to 5 pi over 6 plus multiples of its period, and also 7 pi over 6 plus multiples of its period. Tangent function. Solve the tangent of x is equal, well, plus root 3 is equal to 0. So again, we isolate the tangent function. So tangent of x is equal to negative root 3. Now on the unit circle, remember the unit circle only gives you values for sines and cosines, but the tangent function is the sine of x over the cosine of x. So what I'm looking for is I'm looking for angles for which I divide the y coordinate over the x coordinate. That gives us a negative root 3. So if we look at this, what we're finding is this angle here, which is 2 pi over 3, gives us a coordinate of negative 1/2 root 3 over 2. And if I divide these, root 3 over 2 divided by negative 1/2, the 2's will cancel. So this is going to give me a negative root 3. And also, down at 5 pi over 3, I have coordinates that are 1/2 comma minus root 3 over 2. Again, y divided by x is going to give you negative root 3. So x is going to be equal to these angles. So 2 pi over 3 plus multiples of its period. Now, the period of sine and cosine are 2 pi, but the period of tangent and cotangent are just pi. So we just say n pi. So I also get x is equal to 5 pi over 3 plus n pi. Now, this second answer is not necessary because if I add a single pi, do you notice that I'd run right into that angle again? So if n is equal to 1, 2 pi over 3 plus 3 pi over 3 is going to be 5 pi over 3. So this second answer is not needed. It's actually handled with this. So with your sines and cosines, you're gonna need them both. With your tangent and cotangents, sometimes you don't. Two sine 3x plus 1 is equal to 0. So this has an extra step in here, that this 3x. So first we're going to isolate the trig function. So 2 sine 3x is equal to negative 1. So the sine of 3x is going to be minus 1/2. Now the angles that are going to give us minus 1/2 are going to be equal to 7 pi over 6 plus 2n pi. And also it's going to be equal to 11 pi over 6 plus 2n pi. Now remember, when we get rid of that sine function using the unit circle, we're still going to have this 3x left over. We're going to still have the argument of that sine function, so or the angle. So 3x is going to be equal to those numbers. So your last step is now going to be divided by 3. So x is going to be 7 pi over 18 plus 2/3 n pi. And x is going to be 11 pi over 18 plus 2/3 n pi. Now the last example is what happens if we have a trig function that's in quadratic form. So what I'm doing is I'm composing a quadratic with a trig function. So if I want to solve 2 sine squared of x minus 3 sine of x plus 1 is equal to 0, what this is this is the form 2u squared minus 3u plus 1 is equal to 0, where your u function is equal to the sine of x. So what I'm doing is I'm composing this quadratic with the sine function. We do this because it's easier to factor this quadratic, looking at it in terms of u as opposed to sine, but you could do it up here if you want to just leave the sine there. So I know to factor it's going to be 2u and u. The only way to multiply to 1 is this is going to have to be 1 and 1. And this has to subtract 3, so 2 times that and that. So minus 2 minus 1 is going to be equal to 3. So here I get 2u minus 1 is equal to 0. And here I get u is minus 1 is equal to 0. So solving, I'm going to have u is equal to 1/2 and u is equal to 1. Now we're not trying to solve for u, we're trying to solve for x. So reintroducing that sine function, so the sine of x is equal to 1/2 and the sine of x is equal to 1. We can find the angles for which this is true, just like we did before. So this is going to be pi over 6 plus multiples of its period, 5 pi over 6 plus multiples of its period. And for the sine of x to be equal to 1, we know that that's straight up at pi over 2.